Hi everyone, we are at the Hiking Prosthetic Group 1, or TRED.
In the initial stages of our project, we gathered relevant information from as many primary sources as possible. We conducted interviews with both our client and our stakeholder, Quality of Life's Barbara Springer. Through these interviews, we discovered exactly what our user had in mind in terms of expectations for the device. As you can see, our client Rob Jones is a double transfemoral amputee, and he seeks to better traverse uneven terrain while hiking for an extended amount of time. His current prosthetics do not allow him to do so, so we formulated our needs statement to reflect our design idea. Our needs statement is as follows. Our team seeks to help transfemoral amputees hike and maintain stability on uneven terrain while improving their overall quality of life.
The upper leg system consists of a torsional spring which is attached to a pylon, and that is attached to the bottom tank treads. This system also consists of a pulley system that is implemented on the socket, in which one side of the rope is attached to the waist and the other side of the rope is attached to the bottom pylon. This also has a compressional spring that is affected by the tension that comes from the rope.
Our client, Rob Jones, envisions himself having a cross-country skiing motion using wheels. We developed this idea further into tank treads in order to account for stability and obstacle avoidance. This will be placed directly on the roof of the frame.
After deciding we wanted to focus our design on the main objective of hiking uneven terrain quicker and not on our secondary objectives, such as crossing large obstacles, we streamlined our thinking more towards a snapback type of leg movement. This came about in our popsicle stick prototype shown below. It moves from a hinge at the knee and a pulley starting at the hip, going through the knee, down to a pin at the ankle region. It snaps back from an elastic band running along the front of the leg from the thigh to the shin. Here is an animation briefly showing how the two springs work together to create a step. Don't worry, I will go into better detail about each part after the video. In the resting stance phase, the torsional spring is at its free 180-degree position and the compression spring is fully extended. The pulling belt in orange is completely taut. As we enter swing phase, the quad pulls forward, activating the belt and pulling the bottom of the leg upward so that the torsional spring bends. Fully into swing phase, the quad continues to pull forward, causing the lower leg to bend fully and the torsional spring to be at its maximum position of 50 degrees. The compression spring begins to compress from the belt being pulled forward, storing the kinetic energy of the movement. Nearing the end of swing phase, the quad is fully forward, causing the compression spring to perform its name and compress fully. Since the belt is attached to the compression spring, it lets out some slack and allows the torsional spring to release, letting the leg straighten out and prepare for stance phase. The compression spring eventually releases its stored energy and returns back to its resting position. The torsional spring releases back to its free position at 180 degrees and the leg returns to stance phase.